Hello everybody. So today we would like to talk about how do we actually deploy machine learning model web service that is hosted on Azure. So eventually we would touch upon both the regular machine learning model as well as the large language model. So today we would in this session talk about the machine learning model in general to Azure Machine Learning Studio deployment. For the next session, we will talk about large language model to be hosted on Azure Machine Learning Studio. So here are the options on the web right now for hosting machine learning models that are free. So the best we have so far are probably the Hugging Face bases. So it has free tier, and then the free tier offers 5 hours GPU hours per month. And then it also supports the GUI user interface development of Gradio as well as Streamlit. And then these are also other three options besides Hugging Face spaces that you can use, namely Google Cloud, Rayway, as well as Render. So here are the general process to deploy machine learning model services on the cloud. So firstly, we would introduce the regular machine learning model deployment to Azure ML through AKS cluster. After this step is completed, it would produce the deployed service endpoint, which is a model URL as well as two keys, which are the public key and private key. So after you fetch these two important assets, then you feed it into Inference Web App. And then for Azure Machine Learning Studio large language model, so you can choose them from its model catalog, and then it would actually produce you the managed online endpoints, and then you can use them to feed into your inference web app. So next, let's take a look at this first process first. So here you can see that these are the basically user interface that you will see when you launch your machine learning service studio on Azure. So this is the general architecture for model deployment via AKS clusters on Azure Machine Learning Studio. So basically these are all the assets or instances that we need to create in the whole process. So firstly, you would need to create a compute instance for the machine learning studio. And then you would also need to uh, import assets into the file system of this workspace. So you can see that all of these assets that we are going to talk about actually are built on this Azure Machine Learning workspace, which is something that you have to create for everything to live in first. And then after you created this machine learning workspace, the file system actually already exists there for you. And then the second step you need to do is to create a deployment notebook to sit in this file system. And we can actually take a look how to do that. so here on the left, so you see that after you launch the machine learning studio workspace, right? So over here authoring, so you have the notebooks tab. So after you click on it, you can already see that there's a file system that exists here. So what you will need to do is you actually click on this workspace and then right click on it, and then you can choose create new file, and then here you can choose the different types of files that you can create, right? So here you can see the IPython notebook and also just a simple Python file and other file types as well. So after you create this deployment notebook and almost actually all of the other commands or process, you can author them in this deployment notebook. So the next step, so after, we've already created this um, notebook, right? And by the way, this notebook is actually taken from this tutorial on this Medium page, which is called Deploying a Real-Time Model into Azure Kubernetes Clusters and built the client app by Get And so the next step after you created this deployment notebook, what you need to do is to connect this notebook to the Azure Machine Learning Workspace. So what you do is this step, this first step. So you actually first import this workspace module from Azure ML.core, and then you construct this workspace right from config. And then so after you actually constructed this workspace and then you print this, so you will see the workspace name that you constructed. And so after you do this third step to connect to Azure ML workspace, then over here, right, this next step is actually either construct a machine learning model, or if you already have a model you trained already. So this step you can see, this middle step is basically getting a model, machine learning model ready, right? So after all this train step, so you can see that your model is trained after this step, right? With the metrics of accuracy as well as AUC. And then the next step, after you have a machine learning model, what you need to do is to save this machine learning model into a pickle file. So what you do is you have this model file name, which is a pickle file, right? And then you dump it via this joblib module, right? And then you use run the upload file of the model name, and then also the path to save it into this Azure Machine Learning Workspace, right? So you see that after this step, you will actually see this pickle file, which would sit under your path that you have given it, right? Which is under outputs folder within your workspace, right? So I would also like to explain where this run comes from, right? So the run actually comes from over here when you create Azure Machine Learning experiment, right? And then these two commands.
So this experiment is also imported from the Azure ML.core. And after you save the machine learning model into a pickle file, then you also need to, next step, register the model to the Azure ML workspace. So don't think that after you save the model, then the Azure machine learning workspace already knows about your model. No, so you have to also register the machine learning model to your Azure machine learning workspace. So what you do is you call a register model function with the run the experiment that we just created, right? So over here, so you can see that you would provide several parameters, right? So firstly, where you saved your model pickle file, right, which is the model path, and then the model name, and then so this model name is what you will refer to later after you register your model to the workspace. And then also the properties would also be able to let you specify the AUC metrics by calling the get metrics of your machine learning experiment, right, that you conducted, as well as the other evaluation metrics such as accuracy. And then so after this fifth step to register your machine learning model to your Azure machine learning workspace, then you can start authoring an inference script Python file. So this step of creating a separate Python file can be also completed within the same deployment Jupyter Notebook. So what you can do is using this symbol, 2% symbol, calling the command write file, right? And here we define our file name over here, right? By script file, by store the file name into a script file variable, right? And so you can see that because we actually create this Python file separately under another folder called ES Diabetes Service. So after this step, you can see that a separate folder is actually created for you after this step, right? So on the left tab, right, and then you would also see the separate Python file, which is created under this extra folder after this write file step, right? So one important thing to remember to create this inference script Python file is that it has to include two functions. One is called init function. So this init function is basically to load your machine learning model. And another function which is called run function. So this run function basically performs the prediction on any new data on your trained and loaded machine learning model, right? So we can see that, you also use joblib module to load your trained model. So how do you actually retrieve this model is by the model name that you used to register your model to the machine learning workspace. Okay, so after you register this model to Azure Machine Learning Workspace, then the next step is that you can use the model to run inference service. But before that, right? So basically, you are running this Python file, right? But then we know that to run any Python file, we also have to run it on a Python interpreter or a Python virtual environment. That's how we usually do it on our local development. So the same thing for this cloud environment. So we have to create a Python environment to run this inference Python file. And this Python environment is actually going to be saved in a YML file. So now we will show how to create and save this Python environment into a YML file, which is also something that you can do um, in in this deployment notebook too. So here, so we also wanna basically put it here, right? In this step, right? So to create this Python Python environment in under this deployment notebook. And then after we create this Python environment in a YML file, then we can use it to run our Python inference script, right? So on this left pane, so you can see here, so this step is actually where we can um, create and save this Python environment into a YML file, right? So here, so basically, a Python environment needs to contain all the Python libraries that you need to use to run your script, right? So we use this Azure ML, the core, the conda dependencies module, right? And then so we create this environment by constructing conda dependencies object, right? And then we call the add conda package to add all of the necessary Python packages you need for this uh, running the Python service, right? So, and then we create this folder path that you would save this Python environment YML files in. So here we choose actually the same folder where we would save our Python inference script files, right? And then so and then we write our environment using the serialize to string function for this conda dependencies environment object. So after this step, that we can see that your YML file for the Python environment is created under this folder that we created earlier to save our Python inference script file. And so after we call this print file to see what is our Python environment, that YML file actually looks like, right? So it has name, because if you remember, we actually serialize this environment into string, right, by calling this function. Now we can see that the dependencies are Python version is 3.8.13, and then we have pip packages, and then we have the libraries that we added to the environment as well. And then so after we have the Python script to run the inference, as well as the Python environment that supports the running of the Python script, then we need to combine these two things into an inference config runtime, right? So for doing that, this is the step that we run the command. So we import this inference config
object from Azure and not the core the model, right? And then we give the runtime to be Python, right? And then also specify where our inference Python script is, and also as well as our
environment, Python environment, YML file that represents our environment to run this Python script, and then save this object into an inference config runtime variable. And then after this step, right? So then the next step is the actual model deployment. Um, the model deployment step to the Azure Kubernetes cluster, right? So we need to specify uh, a cluster name for the Azure Kubernetes, right? And we also and then so for that we actually use the module from Azure.core.compute, right? So to basically construct this compute config object, right? So we call the AKS compute object function provisioning configuration function, right? And then we specify where this resource is located, as well as the purpose of this cluster. So here then we created the compute for this Azure Kubernetes cluster, um, right? And then I'll compute for it. And then after we created this compute, then we actually create this cluster, right, on this compute by calling the create function, right? Over here, then we need to provide the workspace that we loaded, and also the cluster name, and also the compute config, right? And so basically we use these two modules, which is the AKS compute is to create a compute for the Azure Kubernetes service cluster, and then the compute target, which is actually to create the cluster on the compute, right? And then we call the wait for completion function on the cluster that we just created. So after this step, then we actually finished constructing the Azure Kubernetes cluster, right? And then um, we also have to create a config for the Azure Kubernetes web service by importing the module from the Azure.core.webservice module, and then we call the deploy configuration function to construct this deploy config. So over here, so okay, so for the deployment, we need Azure Kubernetes cluster, right? And then we also need the deploy config object to finish the model deployment. And then after this infrastructure ready, so we will bring the Azure Kubernetes cluster, the deploy config, as well as the inference runtime config, as well as the registered machine learning, these three things, into play for the model deployment. over here, so you can see that, you know, we get the Azure Kubernetes compute cluster, right? And this is where we retrieve the Azure Kubernetes cluster that we just created, right? And then we retrieve the model that we saved in the pickle file by referring the model name that we registered for the model, right? And then um, we are gonna use the model module to deploy, right? So to deploy the model to this Azure Kubernetes web service. So what are the parameters that we need to provide? So the workspace, right? And then the name of the web service, and then the model that we retrieved, and then the inference Python runtime that we saved in the inference config, as well as the deployment config, right? So the deployment config basically is a configuration for the Kubernetes web service over here, right? And um, so this deploy config is actually different from the Azure Kubernetes cluster, but it's actually for the Azure Kubernetes web service. Okay, so and then later the last one, which is the deployment target. So we're gonna deploy this model to the Azure Kubernetes cluster that we just created. And then after we construct this Azure Kubernetes web service, then we can call the wait for deployment function. And then after you deployed it to succeed, then you can see there's a URL, right, provided here for you for the deployment, and it's running, right? And then so we can take a look that after we print the web services in this workspace, you can see which is the web service name that we just deployed, and then where we provide those here, right? When we were deploying web service to the Kubernetes cluster. And so after we finish, um, providing the deployment for the service, then these are actually the two important things we need to retrieve, as we mentioned at the beginning, which is the model deployed URL for the service, as well as the keys, right? So here, here is where we can retrieve the web service we deployed by referring to its name, and then calling the scoring underscore URI to retrieve the endpoint URI of the deployed model service, and then also the get keys function to retrieve the primary key and secondary key to access this deployed model service. So after we print them, so we can see the HTTP URI for the deployed model service, as well as the key that we need to use for our inference web app. So, so after we get these two important assets, so we can see here is where we will feed them into our inference web app, such as a Flask app, right? So we specify the endpoint where we retrieve, right? That after the deploy model service as well as the key. And then we construct this Flask app, right? So we can see where we would use these two assets, right, in our app. So, um, so one is actually where we would need to use the right for the end point. So here is actually when we call the post function, right, to retrieve information or run this model service through this this endpoint URI as well as the key. So we provide the URL uh, with the endpoint, right? And then our new data that we want to run the predictions on, and then make this post request and send it right to the deployed model service that we would like to get a response from, and then we will get the um, get the predictions right to load it from this returned response, and then um, is where we would get it. So the key is actually being blended in this request headers, right? So as a parameter to provide to the authorization parameter, right? So after you construct this inference web app, so you can see that actually the web app will look something like this, right? And then which I tried is actually the exactly look like this. And then how you would run this web app is actually by calling Flask run right on your terminal. So I hope that you will like this session, and then it will be useful for you to know how to deploy your machine learning model to Azure Kubernetes web service. See you next time. Bye.